two. I can't call part two. The video cut off. That hadn't happened in a long time, so I forgot about that fun thing. So, all right, whatever. Memory got full and it just stops. But oh well. But it didn't. It looks like it saved the video. Here I am. Sorry. Titanium. Okay. We said 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. Now, if I want to make titanium plus 2, in fact, I meant to mention this. If you see on a worksheet or a paper or on a quiz or on an AP exam, draw the electron configuration, write out the electron configuration for titanium plus 2. If they ask you, write it for titanium plus 2. First, even though they didn't tell you, you should just do titanium. First do titanium, then make the adjustment. Same way, write the electron configuration for O negative 2, like I did a moment ago. Or first just do O, and then say, oh, I've got to add 2 electrons. So we do titanium first. Oh, positive 2, you got to take away 2 electrons. Now the rule, as I said, you take them away from the highest floor of the hotel. And so the highest floor of the hotel, 4s or 3d, it's actually 4s. So even though we write the configuration this way, 4s is really higher up physically or farther from the nucleus in general than 3d is. They're really close. It's a weird thing we'll show you later, but this would be a higher floor. So 4s is higher than 3d. Okay, so you lose the electrons out of there. Now, if you made titanium plus 1, you just have 1 electron out. And there are some elements that are that way. They're pretty much in this section in the chart. Pretty much any element in here that's a positive 1, like gold does that, copper does that. If you see anything that's positive 1 in this area, well, then it would lose like 1 electron. Titanium loses 1 electron and becomes titanium plus 1. And it would be 4s1, 3d2. Kind of strange. But then when you lose another electron, there's something about, I didn't tell you about I don't want to confuse you. We know what, I'll get to that. I'll wait and tell you. There are some little exceptions to electron configuration. There are some, I better say this right now. If you do the electron configuration, if you sit down and say, hey, I'm bored today, I think I'll write down the electron configuration for every element on the periodic table. And if you use this and you go through all of them, you're going to get most of them correct. Uh-oh, what is that? Good teaching. Well, the thing is, there are many exceptions, and we don't really have to know the exceptions. They're not going to ask that. There are a few exceptions that you should know about, and I'm going to tell you about those later on. But don't worry about it right now. So if you see somewhere else, if I ask you to write anything on my quizzes or homework or test or whatever, just do it the way I've taught you to do it, all right? Now, it might contradict something that you see somewhere else, but I'm just going to ask you to follow the pattern. We're pretty much going to do the basic elements. But there are a couple of advanced ones that AP would need to know how to do, where they do some weird stuff. They shift around the electrons. And I'm going to tell you all a little bit about that later. But okay, all right, so anyway, back to this. So what is titanium plus 2? You take away 2 electrons from the 4s, and it becomes, really, so 1s2, 2s2, 2p6, 3s2, 3p6. So the 4s, you could just leave off 4s, or you could put 4s0 if you want to. I guess I would put, I might put 4s. I don't know what I would do. If it were the AP exam, maybe I would put 4s0. Maybe I would. Okay? And then 3d2. But you don't have to put 4s at all there. Just because at least you're showing them, hey, I know it came out of the 4s0. That one was empty. Those are the ones that left. All right. So now you're able to do all of A, B, C, D, E, F, G, H on that first worksheet. So this is 2 extra ones. But then there's some more stuff I want to show you. And I think, okay, regroup. All right, short form configuration. I think I've got enough time just to show you short form. Let me do that. And then I'm going to, we'll see. I got a little bit more time here. Okay, so here we go. All right, so we got the Hog Hotel, the helicopter scene, SPDF, and all that. We talked about how it works. Okay, let me go over here. short form configuration, and yeah, that's the first thing I better do. I better talk about short form and the periodic table. Okay, here we go. Well, here's the neat thing. The periodic table is actually designed, the shape of the periodic table is designed based on electron configuration. You'll be like, why didn't you tell that in the beginning? Well, so I've gone, talked, whatever, almost like over an hour on all these videos you've seen. And I didn't want to tell you this until now because I want you to understand the whole structure to it makes sense, kind of. Okay, here we go. So first, on the periodic table, I'm going to kind of draw it like this for a moment. Well, I won't do a very good job of it, but oh well. I'll just kind of come down there like this. Okay, on the periodic chart, oh boy, that's too big there or whatever. Well, I really messed up there, but oh well. These are called the S blocks. Oh, you know what? Well, I'm about to say I could draw it. I could draw it on here with a marker. I don't know if I have another colored marker though. Well, these first two are called the S blocks. S blocks. S. All right, let me talk about what that means for a minute. Everywhere on the chart, these are the S, and on this side are called the P blocks. These are the D blocks, and these are the F blocks down below. Now, what in the world does that mean? Well, a block location for an element tells you the highest room in the Hog Hotel that has an electron in it. It always tells you that. And what's really cool is the chart is made to show you it's based on this. Now there are some exceptions even on this. I'm going to show you there's some exceptions, but I'll pretty much do it this way. This is period 1. Let me try to get to the side. That's period 1, 2, period 3, period 4, period 5, period 6, period 7. So the first floor, Hog Hotel, the second floor, the third, fourth, fifth, sixth, seventh. So it's kind of like the upside down. That's probably why they do it this way. And some books will show this whole chart upside down. But oh well. But there it is. All right, so first floor. Okay, watch how this works. And I'm going to just kind of say it. You might have to run back if you don't quite get it. The first electrons, let's say that all your charts empty of electrons. You start filling them in. The first electron goes right there into hydrogen. 1s1. Everything in this row counts as S1. Everything in that row is S1. Think about that for a minute, and I'll show you. Hydrogen is 1s1. That's easy. Do we have any space down here? I guess I do. Hydrogen is 1s1. Well, let's go to the next. How about lithium? Well, lithium would be 2s1. 2s1. Lithium, right? These are all S1s. 2s1, 3s1, 4s1, 5s1. Okay, well, what does it mean? If sodium is 3s1, why do we know that? The block location, 3s1. What that means is that is the highest hotel room occupied for sodium. The highest hotel room, excuse me, in Hog Hotel is 3s1. So it tells me everything up to 3s1 is completely full. So sodium, its electron configuration ends at 3s1. That means it must be 1s, okay, what's the max? 1s2 maxed out. Then comes 2s2 maxed out. Then comes 2p6 maxed out. Then comes 3s1. So 1s2, 2s2, 2p6. Look at that. So you can memorize it now easier when you know the block location. All right, so these are all that way. How about cesium would be 6s1. So I don't really want to go through this, but if that's 6s1 for cesium, then that means cesium would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s1. So as long as you know how to max out everything all the way, that's another way you can do the electron configuration. All right, but there's even a better way. Another way I'll show you in a second. All right, so if these are all S1, guess what these are? These are all going to be S2. So, S2. So, there is no 1s2. Well, no, that's not true. There is 1s2. It's over there. It's helium. It's not in this location, but that is 1s2. Helium. Sorry about that. It's not put there. But we go down below it. Beryllium is 2s2. Magnesium goes all the way up to 3s2. Okay? Calcium, 4s2. Okay. Now let me show you how the chart kind of works out. What happens, now I want to show you that the chart is designed according to the blocks, the S, P, D, and F. After, on the chart, first comes 1s1, 1s2. Okay, let's kind of forget about that one. What comes after the 1s? Then you start the 2s1, 2s2. Okay, so 2s1, 2s2 comes here. 1s is full, hydrogen, helium. 2s1, 2s2. That takes you to beryllium. What is the very next element going to be after beryllium? Boron. What is that going to be? Well, according to the line diagram, after 2s2 comes 2p1. And so guess what? Boron will be 2p1. Guess what carbon is going to be? 2p2, 2p3, 2p4, 2p5, 2p6. It still works. Everything fits on the periodic table. Isn't that great? So, these are all P1, P2, my ink is going out, P3, P4, P5, P6. I tried to write it the best I could with this thing running out of ink. P1, P2, P3, P4, P5, P6. Okay, so boron is 2, second period, P1. So that means everything up to 2p1 is full. If I want to write down boron, I can just say, well, boron is 1s2, 2s2, 2p1. Boron is 2p1. So everything before 2p1 we got was full. 1s2, 2s2, 2p1. All right. Let me, I think you kind of get the hang of this, but let me do another one. Let's go all the way and do nitrogen. All right, nitrogen is going to be, or I think I got a better idea. Let's do phosphorus. So phosphorus is 3, and then this is a S, 3s1, 3s2, 3p1, 3p2, 3p3, 3p3. Phosphorus goes to 3p3. So everything up to 3p3 is full for phosphorus. So 1s2, 2s2, 2p6, 3s2, 1s2, 2s2, 2p6, 3s2, 3p3, like that. Okay, so everything across tells you phosphorus. So this, the chart, actually turns out that it can show you, you don't need this because you have the chart now. But see, what I tell everybody is, years from now, you might forget about the chart. You might forget where that's the S, the P, the D. You might forget that. But you probably will not ever forget how easy it is to draw this. One SP, SPDF. So let this kind of be the guideline, the law. If you forget things, you can always write that down in a quiz or something, write down on your paper and look at it there. And then know that this is based off of that. So in this chapter, we have quizzes, tests, and all that. The next few weeks, you're probably going to memorize it. You're not going to need this that much, okay? But say that like at the end of the year, the exam comes, or AP before the AP exam. You got, it's been 2 months. I got to review this stuff. Well, you probably will think, okay, well, I know this, and how does it work? Oh, it looks like this, okay? First comes, let me see if I can stand here and do them at the same time as I point to it. First comes 1S, 1 and 2, okay? Then comes 2S, 2S1, 2S2. Then comes 2P, 1, 2, 3, 4, 5, 6. Then comes 3S1, 3S2. What's after 3S2? 3P, 1, 2, 3, 3P4, 3P5, 3P6. Then comes 4S1, 4S2. Now here's a neat thing, I didn't tell you this yet. After 4S1, 4S2, what does it tell you over here? What happens next? After 4S1 and 4S2, then you go to 3D. And that's why these are the D blocks. So 4S1, 4S2, that will be 3D1. I don't know if I can write that all down. Just around with this pen. 3D1, D. Well, here it is. D1, D2. It's going to run out. If I hold it down, it'll work. D3, D4, D5, D6, D7, D8, D9, D10. D1, D2, 3, 4, 5, 6, 7, 8, 9, 10. There are exactly 10 spaces right there for the D electrons. Okay. So if I take for example, actually we did it earlier, titanium. Titanium's block. Okay, now I didn't tell you this. So there's one more story about the Hog Hotel. So the Hog Hotel on a mountain, you know, mountains were formed long ago and from volcanoes and all this. So there was an earthquake, boom, and all of the D floor, the D section dropped down one floor. Okay, so that's a little story to tell you. So even though this is 3S, 3S1, 3S2, and 3Ps, well, this is actually 3D1. After 4S1, 4S2, then comes 3D1. But guess what? After 5S comes 4D, 6S, 5D, 7S, 6D. So you're always going to be after the S's, you're always going to go like 5S to 4D, 4S to 3D. And I'll talk about the F in a minute. That's a little crazy. Okay, so titanium, its block location is 3D2. 3D2. So everything up to 3D2 is full. So for titanium, 1S is all full. 1S2, 2S2, 2P6, 3S2, 3P6, 4S2, 3D2. All right? Okay. Now we're ready to get to those crazy. So if I were to say what is gold, you'd say, well, gold is D9. Well, that's 1, 2, 3, 4, 5, 6. All right, this is period 6. I erased it. 6. So that means that this would be the 5D9. 5D9. But now something else weird happens after 6, and I got to get to that. Okay, after 6S, look at what happens. Always go back to this when you forget about how does this work. Look at this. What happens after 6S? You go to 4F1. What? 6S to 4F? How does that work on the chart? Okay, well, if you look on the chart, and they're kind of getting rubbed off here. After 6S, 1, 2, 3, 4, 5, 6, barium. 6S2. Barium is number 56. So 55, I can't really read it that good, 56. But then on your chart, if you look after 56, it goes all the way. You see 57 here, but then it jumps to 72. So 57 is called lanthanum, 56, 57. But then where's 58? Up, it's down there. 58, 59, 60. Okay, so what happens is this. All right, watch. This is 6S1, 6S2. That count. Count that as 4F1. Now, if I were just to ask you, now this is only for an AP thing, but if I were to ask you what is lanthanum? Lanthanum is 5D1, okay? And actinium down here is going to be 6D1. If I ask you those individual. All right, but what happens is once after lanthanum, it's really weird. After 6S and 5D1, then we go down here and they start to fill up the Fs. Now, when we go down to this element, to 59, for whatever reason, it pulls that electron with it. It's very strange. So you can just ignore that. Count that as F1. That's what I'm trying to tell you. If I ask you for lanthanum or actinium, yeah, that is D1. That's true. But I'm not going to really probably do that. They could ask for AP. They could ask you to know that. But if I ask you anything in the F column, count that as F1. So in other words, 6S1, 6S2. And remember, it's based on this. After 6S comes 4F. So count this as 4F1, 4F2, 4F3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 4F14, you'll count that. Then after 4F14, then you'll count 5D1. It will count that as 5D1, though it's more like a 14, but count it as 5D1, and that's number 71. Then 72, 5D2, and now you're back on track. 5D2, D3, D4. So you never have to worry about that weird counting unless you're doing an element that stops in the F blocks. So if I were to say to you, okay, what is SM? It's called samarium. What is samarium? Then what you would do is you'd say, oh, it ends in the F. So 6S1, 6S2, count that as 4F1, 4F2, 4F3, 4, 5, 4F6. Count it that way. And you'll get most of them right. Not all, but most of them right. So that tells you to count that as F2. I can't even write that. F2, F3. The ink is really going out. F4, F2, 3, 4, 5, 6, and so forth, all along there. Okay,